right, welcome to 8.3. We're going to do a couple review questions here, and then we're going to get you some special right triangles. In our first question here, we're asked to find x. We know that the hypotenuse is the side opposite the right angle, so I'm going to say x squared plus 7 squared equals 12 squared. Simplifying that down, I get x squared plus 49 equals 144. Subtracting 49 from both sides, I get that x squared is equal to 95 square root. And we're going to leave that as the square root of 95. Because I want the exact answer, not some decimal representation, 9.8 or whatever it is. On this one, since we're looking for the hypotenuse length, we're going to say 13 squared plus 38 squared equals x squared. On this one, when I square it out, I'm going to get 169 plus 1444 equals x squared. And when I add them together, I'm going to get 1613 equals x squared. And if that's a perfect square, I would simplify it. But if it's not, I'm going to leave it as the square root of 1613. Because I want the exact answer, not some decimal, 40 point whatever it is. So on this one, they want us to determine if this is a right triangle. So I'm going to start out by graphing it. And so I get Q is down there, R is at 0, -1, and S is at 4, -1. And so I know this length is 4. And so if I find the distance formula here, I need to have the 3 lengths to be able to do this. Well, the length of RS is 4, because from 0 to 4, it's a horizontal line. I can just count that. But I need to find the other 2 lengths, so I'm going to use my distance formula to find QR. And I'm going to go with x2 minus x1 squared plus y2 minus y1 squared, which gives me 2 squared, or -2 squared, which is the same thing. 2 negatives makes a positive, plus another 2 squared, which gives me 4 plus 4 is 8, which is 2 root 2, or the square root of 8. I also need to know the length of QS, and so I'm going to use the distance formula there again. So 4 minus 2 squared plus -1 minus -3 squared. 2 negatives makes a positive. 2 squared plus 2 squared gives me that 2 root 2, or the square root of 8 again. So I want to know if 2 root 2 squared plus 2 root 2 squared equals 4 squared. Well, we know that this is the square root of 8. Square root of 8 squared gives me 8 plus 8 equals 16. So, yes, it's a right triangle. Another warm-up question: determine whether the set of numbers can be measures of the side of a triangle, and if so, is it acute, obtuse, or right? Well, the 2 shorter numbers, not the ones listed first, it's the 2 smaller numbers, has to add up to greater than the third. So in this case, yes, it's a triangle. But we have to determine if it's equal to, greater than, or less than by finding these numbers. So I'm going to take 16 squared is 256, 30 squared is 900, and 33 squared is 1089. And if I add these together, I get 1156 is greater than 1089. So since the a squared plus b squared is greater than the c squared, we know that this is an acute triangle. Remember, if a squared plus b squared is greater than c squared, it's acute. If a squared plus b squared is less than c squared, it's obtuse. And if they are equal to each other, it's all right. All right, so I want to determine if these are an acute, obtuse. Again, if I can, the two smaller numbers have to add up to greater than the third one. And so it does, so I'm going to do 5/8 squared plus 3/2 squared and 13/8. And I get 25/64 plus 9/4, 169. And if I add, I'm going to use my calculator here because, my goodness, I don't think I can do these in my head. Plus 9 divided by 4 gives me 2.640625. 169 divided by 64 gives me 2.640625. I'm going to go with their equal, and this is a right triangle. All right, so that good review over those things. So we talked about triangles, and we're going to talk about special right triangles, ones that have the angles 45, 45, 90, and 30, 60, 90. So we have 45, let's try that again, 45, 45, 90, and 30, 60, 90 right triangles. The side ratios of this are 1, 1, square root 2, and the ratios here are 1, square root 3, 2. Okay? So side ratios are going to stay the same ratio. And here's a theorem. Please pause this so you can write it down. So what the theorem said after you wrote it down is if you have a 45, 45, 90, we know sides opposite equal angles are equal, so that's going to be 9. And we can use the Pythagorean Theorem that says 9 squared plus 9 squared equals c squared, 81 plus 81 equals c squared. 162 square rooted equals c, which is the same as 9 root 2. What a coincidence. The theorem just said that the ratio is 1, 1 square root 2. So if these are the side ratios that match up to 1, then this would be 9 times the square root of 2. So this is 9 times 1, 9 times 1, square root of 2 times, or 9 times the square root of 2. Same dealio here. If we know that it's a 45, 45, 90, then the hypotenuse has to be the square root of 2 times what the side lengths are. Even if they have radicals in them, you have to multiply. Square root of 2 times square root of 2 is the same as square root of 4, which is 2, which gives us 12. So the side length is 12. So in this one, if we know that it's a 45, 45, 90, we know that this side over here, opposite the 45-degree angle, would have to be the same as the other side. So if I had a 7 over here, it would definitely be a 7 over here. Well, we could use Pythagorean Theorem, but we know that it's already going to come out to be 7 square root of 2, or square root of 2 times whatever the side lengths are. Same deal here, which gives me 16. Square root of 2 times square root of 2 is just 2. And this one's a little bit different than the previous examples because they give us the hypotenuse and they want us to find the legs. Well, if the ratios are 1, 1 square root of 2, we know we have to divide whatever this is by the square root of 2 to get to the other side lengths. So I'm going to rationalize my answer, and I get 8 square root of 2 over 2, which simplifies to 4 times the square root of 2. So both of the side lengths are 4 square root of 2. More of the same. So if this is 6, divide that by the square root of 2, the hypotenuse, to get to the legs. Rationalize, rationalize. I get 6 root 2 over 2, or 3 root 2. Both of the side lengths would be the hypotenuse divided by the square root of 2. In here, we know that we have a quilt. Has a design shown in the figure in which a square is divided into 8 isosceles. Again, isosceles has 2 sides that are equal to each other. Isosceles right triangles. If the length of one side is 3, what are the dimensions of everything else? Well, this side would be 3 halves, or 1.5 inches. So that's 3 halves. That's 3 halves. And this would be a 45, 45, 90 right triangle. So I know this length over here is 3 over 2 times the square root of 2. So the hypotenuse would be 3 square root of 2 over 2. And just so you know, I have yet to find that length on a tape measure. And my grandmother, who did a fair amount of quilting, would have been like, what kind of answer is that? Give me the real deal. So sometimes you need the real answer. And so for my grandmother, I would say this is 2.12 inches. And if I was so inclined, I would probably take 2.12 inches and I would multiply this 0.12, so minus 2 equals, and I get 0.12 times 16, and I get probably 2 and close to 1/8, 1.9, so almost 2/16. So 2 and 1/8 inches would be about as close as I can get with 1/16 of an inch. So the second type of triangle, why don't we stop there and we'll get to the other one because we're going to run out of time here.